MolySym.
Hello, I'm Hannah Sevy, and I'm a professor of science education and chemistry at University of Massachusetts, Boston. I'm working with the MolySym project. I have developed a couple of lesson plans, and these are examples, the examples through which I will try and demonstrate the direction that we're going with this work. So the first lesson is a way that students can learn about some of the ideas around the shapes of a molecule. The basic idea is that really what's behind all of the MolySym lessons is that matter is particulate, and that the behavior of matter can be explained by a theoretical understanding that's based on how particles behave. So here is a particle of the ethane molecule. This is one ethane molecule, and this is attached to a computer. And this is the angle, this is a single bond between a carbon and a carbon, and this is the angle through which the molecule can be rotated. This CH3 can be rotated around this CH3. And you can see that where these hydrogen atoms here line up, there's more interaction between the hydrogen atoms than when they're unaligned here. So this angle that we're rotating around is called the dihedral angle, and the energetics of this are reflected in a potential energy surface, where we see that the molecule is most stable where there's less interaction, so where there's less steric hindrance, as we call it. And you can make a graph of the angle that it's rotated around. If you start out at say 0 degrees, you can rotate this whole thing around 360 degrees, and you'll see a pattern where there's a lower potential energy, which is more stable, a higher potential energy where they overlap, another lower potential energy, higher potential energy, so on and so forth. So it looks a little bit like a sine wave. And as students take this molecule and they rotate it in their hands, they see the response on the computer for what the potential energy surface does, and they learn to associate the particle level behavior and the energy of what that behavior looks like with the behavior of the material, and why the energetics exist in here. Now we take that understanding of students beginning concepts with understanding the angles within molecules and really the interactions, because the interactions are all dependent on repulsions and attractions. So what's going on inside this hydrogen atom here is that the electrons are near the outside and electrons are negative, and the electrons on this one are negative. So when they're closer to each other, they repel more, and when they're farther away from each other, they repel less, and so we have more stability. By playing with these molecules, the students have the opportunity to take a look at the potential energy surface. They can look at how the dipole is different depending on what orientation the molecule, the internal parts of the molecule have, and they can experiment. Each student's experiment will be different, and each student will come to his or her own conclusions and construct his or her own knowledge. And this hardware and software, this interactive molecular modeling system, gives students the opportunity to go through that process with a lesson plan that's designed to ask the questions of students to cause them to figure things out.